I'll start. Just give me 1 minute for my notes. Awesome. All right. Okay, so you can still see this screen. I can see the chat. If there are any issues, I'll look here. So yeah, as Deepti mentioned, we saw a lot of excitement on this project throughout this conference. And Dave, Cohen, and Ori already gave a good overview on the need for a new state-of-the-art execution engine called Velox. But before I go into more updates on this project, I want to quickly share some of my thoughts as well on why I feel this project is very important. Yeah, as Deepti mentioned, I have a passion on trying to bridge the gap between HPC and big data. So I pursued my master's and doctoral studies in high-performance computing, and my interest has always been to bridge the gap between big data and HPC. The main reason is big data has a lot more user base, like almost probably a 100x factor compared to HPC. So any change in the big data will make a huge impact. So I always wanted to sort of apply HPC in the big data applications. And I actually read a blog once where the author mentions that HPC and big data are actually like twins separated at birth. So they are all originated at the same time, both originated at the same time, but they took different paths. And unfortunately, there are a lot of similarities between the both, but the ideas often exchange between these two domains. And I'll share why I feel Velox provides an opportunity to future-proof the execution layer by providing a platform for both domains to unite. So I'll just take a couple of minutes to go through what my thoughts. All right. So the HPC community actually started thinking about the implication of the near end of Moore's law and Dennard scaling almost a decade ago. And as Ori mentioned today, adding more nodes is not going, or more compute or more hardware is not going to solve the problem because we are hitting the power barriers. So the implications are that the hardware will be more heterogeneous with deep memory hierarchies. And we're already seeing that today, right? So if you get a MacBook Pro today, the new M1 processor that does not have just the CPU and GPU, but also comes with a neural core. You can specify how many cores you need. And this is a prime example that the processors are going to be more heterogeneous and with deeper memory hierarchies. And the HPC community actually started looking into handling even more future use cases like dark silicon, where the idea is you have various kinds of processing elements, heterogeneous processing elements, and you only turn some of them on and off to keep the power budget constant. So there are even more futuristic use cases of in the HPC world on how to write applications for future hardware. And the HPC community also developed runtime extensions to handle heterogeneity. So if you look at the recent papers there, you'll see a lot of offloading architectures, compiler and runtime techniques to take advantage of GPUs. But the big data domain has always lagged behind the HPC community to take advantage of these computing trends. For example, if you look at the adaptation of vectorization and code gen, the database community adopted them much later than the HPC community. The vectorization and code gen have been sort of well studied in the HPC domain for quite some time. And the main reason probably behind the slow adoption is also the high bar of productivity for big data applications, right? I think because the domain is large, you have a higher bar of quality that needs to be met. So for that reason, probably the adoption is slow. But yeah, we started to see projects like Velox in recent times. So Velox is not the first one, right? So we have Photon from Databricks, but unfortunately, they're all closed source. So I feel like building runtimes specifically for this modern heterogeneous hardware is a huge endeavor. And I strongly feel that open source is the right way if we want to pull this off successfully and make it future-proof. So this way, a HPC community can make their research. So I already see some students at TU Munich who's working with Velox and Prestissimo and trying to run some research experiments on it. So it opens a wide range of possibilities if you open source such complex or such libraries where a single team cannot really pull it off. So I'm really excited about Velox and its future. And also, I noticed that lack of standardization has always been a bane for big data products compared to HPC. So I see that open source sort of brings some level of standardization. For instance, if you look at Parquet, even though it's not the best file format, it's now widely adopted. Even though Arc is a missed opportunity, but open source projects do enforce some sort of standard. Like Arrow, again, is one of the example. Most databases now sort of claim that they are zero copy compatible with Arrow. So they have some standards set before they introduce new ideas or layers. All right. So with that thought, this is going to be the outline of my talk today, I'll give a quick recap of PrestoDB and Velox, and then I'll cover some of the supported functions in Velox currently. I'll talk about the Parquet and S3 support that we recently added as part of the community effort. Also, what is the current status of the TPCH queries? And I'll briefly talk about the experience with the open source collaboration and what some of the thoughts there and our future roadmap. I'll not be covering some of the low-level details like the threading model and memory management in this talk because it's a smaller talk, and we cannot cover them all in depth. So we'll mostly add those details in a documentation or on a blog post part of the Velox project. So stay tuned for those. All right, so what is PrestoDB and Velox? Ori earlier already gave a brief overview. I'll quickly cover again on this presentation. So the idea behind Velox is to have an open source, state-of-the-art building blocks for vectorized execution. So the idea is build a library with enough components so that you can build more tools on top of it. So with that way, you can have consistent semantics across different workloads, right? Like you can have interactive batch streaming in AI, and having this building blocks help provide consistent semantics across all of the various workloads. And the idea is also to maximize hardware resources, as I mentioned. So maximizing the hardware has multiple benefits. You essentially reduce the number of nodes, so which means on premise you need fewer nodes, so lower power costs, and on cloud, which means you have to pay less for your query. So you need fewer hardware, you reduce your cost significantly. And the Velox library is written in C++ for maximum efficiency, and that's obvious. C++ is sort of easier to optimize the hardware. So there's no GC storms. They don't have to pre-allocate memory like Ori's mentioned. For the VM we have more control over the hardware, and we can aim for better optimizations. And the Velox library internally also has some nice optimizations for high performance. So for example, it uses dictionary encoding to enable zero copy execution. It has some custom encodings for string, array, and maps to allow vectorized evaluation of expressions as well. So the conditional expressions are always control flow nightmare. So you branch, but if you're able to vectorize them, that's sort of a very good deal for high performance computing. And these custom encodings allow us to vectorize conditional expression evaluations as well. And there are also other tricks like using array-based aggregation instead of a hash table when your elements can fit. And so some of these nice tricks that help with high performance. And the other change is also semantic cache. So unlike a traditional cache, which is obvious to the context, the idea here is we want to introduce some context to the cache that knows like what is probably more aware of the context. So I'll probably there'll be a blog on this sometime soon. But yeah, the idea is to have some context to the cache so that you can be smart about what to evict and what is important. And also, ARIA style filter pushdown is very important for table scans. So you want to avoid loading the data or transferring the data from storage as much as you can. You want to push predicates to the scan step or the storage layer as much as you can to avoid any unnecessary data transfer. So ARIA style filter pushdown is already supported in the Velox library. All right, so now we have Velox that basically provides the building blocks for execution. Like it has a notion of tasks, drivers, operators, functions, and expressions. And now we have to use this library to build execution engine. So PrestoDB is a great tool to test the benefits of the Velox library. So in order to test the library, we need to have a layer between the PrestoDB and the Velox library. So in that layer is called Prestissimo. Essentially, Prestissimo implements the Presto Worker REST API with Velox as the building blocks. So the idea here is you have the worker, the PrestoDB worker in C++ using the Prestissimo and Velox implementation, and the coordinator is still in Java. So on the left, you can see that the coordinator is the existing PrestoDB coordinator. It's in Java. It does all the less compute-intensive tasks like SQL parsing, optimize the plan generation, and also managing the distributed execution. But the actual execution happens on the Prestissimo workers, where you can see on the right that you have different stages of the PrestoDB workers, and they're all, in this example, you have one stage of scan plus partial aggregate, where you use the Velox library inside PrestoDB to implement the table scan and load the data from the storage, like maybe S3 or HDFS, and then you have a final aggregation stage where you aggregate the whole thing. And the black lines are basically the control path that is in HTTP and JSON, and the orange paths are the data path, which use a custom binary columnar format for transferring the data. All right, so now let's look at what functions are currently supported in the Velox library. And one thing I like with Velox is that it has very good documentation already, and it keeps improving day by day. And there are also examples in the library that you could use for reference. So it's very nice for beginners to start looking into Velox because there's enough documentation and examples to begin with. So today, Velox supports a wide category of functions. So there are functions in the mathematical functions, array map functions, data and timestamp functions, hyperlog functions, and the whole list of different categories. And there's also good documentation around this to explain what are the semantics of all these functions. And like I said, it just keeps improving with examples and more explanation. So the documentation also has what exact functions are actually implemented. There's a nice UI in the documentation to see what is the current coverage. And there are two maps in the UI, the two tables essentially. One table shows all the functions that are implemented, and one table shows the most popularly used functions and what is the current implementation status. So on this slide, you can see the most popularly used functions coverage, and all the functions highlighted by the green are those that are already implemented and work well, and the ones in the white are yet to be implemented. So if you're interested, or if you want to add more functions, or if you want to add one of these functions, we have documentation for that too. So if you go to the Velox documentation, we have guides to help you implement your own functions, or implement some of the missing functions as well. So like I said, there's a good documentation, there's good coverage in the project for even beginners to get started and add and make changes to the project. All right. So again, there's a lot of documentation about functions on the Velox open source documentation page. So I would recommend you to go there to see the whole list of functions that are available. I couldn't fit that in a single slide, so I just put the most used functions in the slide that are available. All right, so let's move on to the Parquet and S3 support. So again, this was added by the community over the last 4 months since the Velox project was open source, and I'm really excited to see all the support that was added. So we added Parquet support, S3 support, and you'll see in the next slides we actually got most of the work for TPCH as well. So in the Parquet support, we had this contribution come from engineers at Intel. And the current idea is we didn't want to re-implement the Parquet parser because I think there are two versions already available, one in DuckDB and one in the Arrow project. So since we already used DuckDB in the Velox project as an embedded library to test as a reference database, so we basically validate all the functions and anything that we implement using DuckDB as a reference database. So that way we'll know if the implementation is correct, and we have unit tests and all the fuzz testing around that to intensively test whatever we implement. So since DuckDB is already present in the library, we thought it's a natural way to use that for the Parquet reader as well. So we've wrapped the current implementation around DuckDB's Parquet reader, and it is still a work in progress. There's still some loose ends to tie, but most of the work is already there, and it is in the Velox project. We just need to tie in some loose ends. And the other good thing with the DuckDB Parquet reader is that it supports partial filter pushdown, which is again similar to the ARIA style predictive pushdown. It helps support filter pushdown, which helps read only the data that is required for processing. It helps avoid loading redundant data. And also the DuckDB's in-memory format is similar to Velox. So that helps us sort of map DuckDB vectors to Velox vectors without any overhead. So we have zero copy for most types, and there's work to sort of make zero copy for the remaining types as well. And also I saw in DuckDB's documentation that they are zero copy with arrow. So transitively, Velox in-memory format is also zero copy with the arrow in-memory format. So if you have applications that use arrow, then Velox will be a good fit in that domain as well. And the most interesting thing I like with the Velox project is that most of the modules are pluggable. So the API and the library has been designed to make all the features pluggable, so that if you don't want something, you don't have to build that in the library. So that's the story with Parquet. Like I said, there's still some loose ends for the full end-to-end support, but most of the work is already there. And S3 support, this was again added in the last couple of months by engineers at Ahana. I was also a part of this project. And we essentially use the AWS C++ SDK to implement the S3 file system. We extended the Velox's file system API, and we build the S3 file system using the AWS C++ SDK. And it's also pluggable. So if you don't want it, you can avoid it from the build. And also, we continuously test S3 support using the Circle CI coverage using MinIO. So it will make sure S3 support doesn't break by other changes. So having CI support is sort of the other thing that is nice with the Velox project. That it pretty much covers all features, and there is some robust coverage with both debug and release builds and so on. All right, so yeah, so we're 20 minutes into the presentation, so I guess we have 10 more minutes. So let me move on quickly. So how does the loading of Parquet from S3 look like, right? Then, so Prestissimo, like I said, implements the Presto worker REST API. So the control plane accepts a post request with the query fragment from the coordinator. The fragment is compiled into a plan. The plan is then mapped to the Velox library. And then the Velox library, basically, we use components that are required to load the data, like the task drivers are always needed. And we have the table scan operator that uses the connector abstraction. And we have a Hive connector implementation of the connector abstraction, which sort of instantiates the reader abstraction for the S3, for the Parquet reader instance and the S3 file handle as well. So this is the pretty much flow. Again, this is the high level. If you're really interested in the low level details, we'll probably add another blog, or you can feel free to ping us on the Slack channel. I have a link to the resources towards the end, so you can use those resources to sort of talk to us about how things actually work under the hood. All right, so let's move on to TPCH queries. When Velox was open sourced, we were curious to see if it had enough functionality to cover TPCH, because that's a popular representative benchmark of workloads, right? So we ran TPCH queries and saw that only one query ran out of the box successfully when the project was initially open source, and the open source community was also building around the same time. So we created a list of missing features and posted them on GitHub issues. That's the way we track missing features in the Velox project. And then we found out that the missing features had varying complexity. So some needed like deeper support for left outer join, some or add new data types, and work around the correlated subquery support. So all these issues were picked up by various partners, like engineers at Ahana, Meta, ByteDance picked various issues and implemented the missing features. And within the last 3 months, we're able to get almost 19 out of 22 working from one query using the community's help. So that shows how active and how enthusiastic the community is. And we communicate asynchronously over Slack to solve these issues. So in fact, one of the Intel engineers is in Russia with the 12-hour time zone difference. And we are able to sort of work across the globe using asynchronous communication over Slack and sort of collaborate well in this project. And yeah, it was a fun experience so far working. And so we added support for date type to get TPCH working. We had to add support for left outer join. There's partial support for correlated subqueries, and all the remaining 3 queries that still need work need some more support for correlated subqueries. And with that, I think in the next month or so, we should have everything working and we'll probably then look into the performance and see how that looks. All right, so I already spoke about the open source collaboration. So we were able to achieve a lot just in the span of a couple of months that the project has been open source. Again, with a small team of engineers from ByteDance, Ahana, and Intel, and Meta. And yeah, so we were able to add features for TPCH and as a community, we were able to greatly improve Prestissimo and Velox. And the community is also very active, and the PRs are promptly reviewed and addressed. Pretty much a day or two is the turnaround time if there are not many major feedback issues to address. And also, like I said, the documentation up to date and is very useful for beginners to get started. The community also publishes a monthly newsletter to keep people abreast of what was implemented in that month. And yeah, we have the Velox Slack channel to asynchronously communicate and collaborate on the project. So yeah, this is an example of a monthly update for November. We usually release in the end of each month with all the updates in the project. All right, so future roadmap. We want to enable Prestissimo and a Presto customer near you. Continue to add more features for functionality and performance. Harden and benchmark the library by running various workloads. Add I/O optimizers as a target for the cloud and object stores, and then move on to support all the TPCS queries as well. We want to get those representative benchmarks working in Velox as well. And these are some resources. I don't know if the slides will be available, but yeah, we can provide them later on chat if needed. And yeah, I heard that in these days presentation is not complete without a hiring slide, so this is your hiring slide. We are hiring at Ahana. That's the end of my talk. Thanks everyone for being here, and I'll be happy to take questions.
Thank you, Deepak, for the great session. Folks, if you have questions, go ahead and type them in the Q&A or the chat. Either is fine. All right, we have a question for you, Deepak. So why was thrift not used instead of HTTP protocol?
Yeah, it's again all good questions, like all good strategies. We still HTTP was already implemented on the Java side, so we just went with that on C++ side to make things faster. But thrift is one of our on a roadmap to sort of use as the protocol to use for the protocol. So yeah, it is on a roadmap, but not high priority at this point. We want to get more functionality in on workloads first.
Great. And curious, I'm guessing TPCDS is up next, as you mentioned. Perhaps a lot more operator coverage needed for that?
Yes. We still have to, yeah, like I said, it's the same process. We will get the TPCS benchmarks, run all of them. We'll sort of capture all the missing pieces and create GitHub issues, and the community can sort of pick up pieces and implement them. So it's same story like TPCH.
All right. Well, thank you so much, Deepak, for a great session. Fantastic to see the C++ native worker, Velox and Prestissimo kind of bringing it together. Looking forward to a lot more progress at the next PrestoCon.
Yes.
And hopefully have all, definitely 21 queries of TPCH, but 99 queries of TPCDS running as well. No pressure. Thanks again. And thanks everyone for the session. We are wrapping up here and moving over to the next one. Cheers. Thank you.